All right, good morning, everybody. It's a pleasure for me to be here. Indeed, I've been working here a few years ago, so it's great to see everybody. It's great to meet back some old friends. Thank you, Caroline, for a great introduction. And I'd like also to thank the organizer for putting together such a great event, a very smooth organization, and I think they should receive some credits for this. So my name is Michael Figuier. I'm French still, and so I hope you can cope this morning with my accent. That's still here after a few years, and probably here to stay for a very long while. So I work as a software engineer at Instagram, and we basically provide a database infrastructure for application developer at Instagram. So we're mostly on the transactional side of the database infrastructure, so not for analytics, but really to handle all of the production traffic to handle the Instagram scale. So when I've been invited to talk here, I've been thinking what's actually particular about what we do at Instagram that would be worthwhile sharing. And I've actually thought that it probably boils down to scale, to the scale that Instagram obviously experience, which actually kind of forces us to be much more disciplined in the way we do things and in the way we design our infrastructure, in the way we operate it, test it, plan for its capacity, and the way we automate everything. And so I'd like to share a few of this experience and how we work with our application team to deliver them an infrastructure that allows them to keep scaling, growing fast, and innovate, of course. So while talking about scale, as it's been said, I assume that most of you are familiar with Instagram. Just 8 years after being launched last summer, it has passed 1 billion monthly active users. Many of them are in France, so I hope some of you are part of them. And while it started as a photo sharing app, it's been extending its business to also toward video sharing. Later, stories have been added, which has become since then like an extremely popular feature with 500 million of daily active users. Instagram has also launched a few other services. Well, we've got a private messaging platform on Instagram. We also have IGTV, which is a mobile video sharing platform. And some of you probably have noticed that lately we've been pushing a little bit more into shopping with Instagram Checkout, where you can actually purchase any goods that you see on any Instagram post and check it out directly from within the app, which I think will be a pretty powerful platform, which is growing pretty fast. And so, again, it boils down to this scale and the fact that many new features kept being added, the service is growing fast, and so we deliver this database as a service internally to all the application developers. And this database as a service is implemented with Apache Cassandra, which I assume many of you may be familiar with. It's a fairly popular large-scale database. And so at Instagram, we've got several thousands servers running Apache Cassandra. So at peak times, that might be tens of millions of queries per second. So that's a fairly extreme scale, and that's a very challenging environment. We are growing. The entire Instagram infrastructure is hosted in the Facebook data center. And this infrastructure is growing rapidly, logically, along with the scale and along with the new use cases that are being added. So new data centers are being built regularly, and the number of data centers keep growing. And we keep several replicas of each of our data on each data center for durability as well. We also customize Cassandra at Instagram. We've implemented our own storage engine, which I won't cover it, but feel free to talk to me about it later. This is not meant to be a talk about Cassandra itself, but just as a quick reminder for those that are not familiar with it, Cassandra is a pure peer-to-peer database, linearly scalable, so you can keep adding more nodes, you can keep extending your cluster as you need. Some server can die, it doesn't matter. An entire data center can die, it doesn't matter. You've got enough replica and you won't have any interruption of service, or mostly none. It's a great architecture for us, so that's why we've picked Cassandra at the end of the day. So all of this database as a service, we actually expose it to our application team in a fully self-service manner. We want our user to be able to just go on a UI and say whatever they need, tell us when they need to create a new use case, which typically map to, they will use a kind of simple UI like this. They will tell us the kind of use case they need. It will typically map directly one-to-one to a table, probably, and we'll actually work together with them to plan upfront for the scale and all that. And the life cycle of a use case at Instagram is a lot linked to this interaction with the application team. Of course, at our scale, it matters a lot. Some use case may need a few thousand of query per second. Some may need several millions of query per second. And so, well, as you can imagine, it's a fairly different problem to anticipate and to plan for. The capacity planning is totally different. So we work together with them. We build a cluster for them in a dev environment, typically mutualized. We estimate the workload, and then we deploy it either on mutualized or dedicated cluster in production. So we've got this constant interaction with our customer, and what we try to do is actually also to expose to them an abstracted API. We do not expose anything Cassandra to them, and that's something we've been extremely happy about, this abstraction layer. I think for a company of our scale and of our size, it's been a great choice for us to expose a fairly simple, abstract, high-level storage API where people just express in their application all their needs, and they don't have to tie their code directly to Cassandra. And this gives us a lot of flexibility, because this way we can actually remap any of this API to a different database tomorrow if we want, or optimize all of this query in a different way, or whatever. And this abstraction is actually not just purely at the API level. We also we literally have a storage API gateway layer in between our backend and Cassandra. Most of the Instagram backend is actually developed in Django, so we are probably one of the largest Django deployments in the world, actually. So this storage API, this intermediate storage API gateways turned out also to be a great abstraction for us, a great design for us, which has served us very well. And for one thing, in particular, testing. It turns out that it gives us a lot of flexibility to do whatever we want, because we sit in between our user and the database, so we can do whatever we want. We can take the traffic, duplicate it, tweak it, change it, test it, whatever. We can load balance it the way we want. We can do many things. So let's talk about a few of these kind of things that we do. For instance, we can do some canary testing. Canary testing, maybe some of you are familiar with it, probably most of you actually. As a reminder, it's about taking just a small percentage of your entire fleet of servers and deploy a new version on it to experiment with real production traffic, how things are going. Turns out that production traffic is something that cannot be simulated very well, so you can always try to use some query simulator or with random workload generation, but it's very different from production traffic, and that's something that we love to experiment by ourselves. So this way we can experiment all of our customization directly with it, and that enabled us to be more aggressive with deployment. Actually, this entire storage gateway is running on continuous deployment and is redeployed every day. The continuous deployment is something very important at Instagram and Facebook in general. Actually, the Instagram backend is redeployed many times a day, many times a day. So it's really part of the move fast culture of Facebook, I think, to keep deploying and iterating very fast. So another thing that it enables us to do is shadowing traffic. This also is a very powerful tool to take the entire production traffic and shadow it, duplicate it to an extra cluster for testing purpose, to experiment what can be done, to do some capacity planning, to test a new version, a new storage, a new database maybe. And this is an extremely powerful abstraction because it allows us to validate permanently all of our new changes and all of our tweaks in our gateway, storage gateway. And so that's something also that has been extremely powerful for us. Something we do constantly as well is load testing. And for this, I think that compared to what I've seen commonly in the industry, Facebook has a very particular approach to load testing. Typically, load testing will involve setting up a test cluster, somewhere on the cloud, and having some workload generation that will send a somewhat equivalent amount of traffic as the one you expect to see in production. And you will try to estimate what's the maximum number of queries per second that your infrastructure can handle, or at least handle properly. And that's not at all the way we do it. The way we do it is actually we will have an automated load testing in a development environment or even in a production environment where it's directly the load balancer that will slowly increase the load on a specific cluster, on a specific server, and on a specific data center, so that we can estimate actually the maximum capacity of a single data center. So here, in this example, the data center C will take 2.3 times the load than the other guys are normally taking. And so we will be able to estimate that they can totally handle, well, an entire loss of one data center because they will be able to handle the extra load. So, and the value of this approach is that it's done, again, with some production traffic, so it's not some kind of simulated environment. It's a real thing, and it allows us to have a real estimation. So the way it's done is actually by slowly increasing the traffic on the given data center until we see some metrics that start to not be very satisfying, in which case we back off our approach and we try again. So it can be done on either a data center or a single server when we want to estimate what kind of load we can handle on an entire data center or single host. So that's a pretty powerful tool for us. We also do a lot of drain testing, where we will actually drain an entire data center, an entire region, and evaluate how the entire infrastructure is coping with this situation. So that, in a way, it's extremely similar, or if not identical, in this example to the Chaos Monkey and Chaos Kong approach of Netflix, which is really don't try to run away from the outage you will see in production. They will happen, so just accept it and embrace it and just be prepared for it. So drain testing are actually happening pretty much weekly in our environment. We always know that a loss of data center is not an issue. Talking about data centers, there's actually something, one last thing that's very particular to our infrastructure that I'd like to share with you this morning is the way we handle the scale of data centers, the growth of data center, and the geolocation of all of this data. So the problem is that Facebook is rapidly growing its number of data centers, and while you may think, well, that's the very problem of big tech companies, it's actually tomorrow the problem of everybody in this room, because after all, internet has made all of our business potentially very globalized, and it's something that's very desirable to try to locate all of our data in the data center all over the world that are offered to us by the major cloud vendor. And so, as a consequence, it's something that you may want to look forward to store to store a copy of all of your database in many of these data centers, so that you can answer more rapidly with a lower latency and offer a great experience to all of your global users. The problem with this approach is that as you keep adding and you're more and more greedy with your wish to offer great latency to all of your users, well, you're rapidly growing the number of data centers and the number of potential replicas. And so if you keep several replicas for each of your data in each of the data centers, you may end up with dozens of copies of your data, which will start to become a problem in terms of cost, in terms of operation, and in terms of scale. So the way we deal with this is by actually observing that what we want is not really to have some copies of the data all over the world, but to have some copies of the data close to the user. So for this, we actually, if we boil down a little bit this problem to just US and Europe, we actually constantly monitor for each of the user the typical location from which they are requesting data, and if this location end up changing at some point, which at our scale happens very often for many users, well, we migrate this data from one region to another. And so, in other words, we end up creating some group of replication based on the geography for depending on the actual location of our users. So this way, if you're using Instagram from Europe today, and maybe you're spending a month of vacation in the US tomorrow, well, it's very likely that your data will be migrated to the US during your stay in the US, and when you come back, it will follow you. And that's actually a great approach to reduce the number of replica globally and to keep while offering a great latency to our users. So great for efficiency, great potentially also in today's world with fast-moving regulation. It can be also a great way to cope with all the needs of that we start to observe in many countries all over the world that start to demand for some kind of data that they're stored exclusively in some part of some given geographical area. So I believe that this is some kind of feature that will be seen more and more and will gain more and more attention over the next few years. So as a summary, we really end up with this approach with two distinct clusters that are entirely partitioned, one for the US and one for Europe. So that's what I had for you this morning. I just wanted to share with you a few of the things we do at Instagram. I will actually be here for the entire day, and I'm happy to talk. I don't speak English, so speak French so often in my daily life. So I'm more than happy to talk a lot today. So don't hesitate to come to see me.